The UH-60 is a 4-blade, twin-engine, medium-lift utility military helicopter manufactured by Sikorsky Aircraft. Sikorsky submitted the design to a U.S. Army competition in 1972. The Army designated the prototype as the UH-60A, and selected it as the winner in 1976, after a fly-off competition with the Boeing UH-61. Named after the Native American war leader, Black Hawk, the UH-60A entered service with the U.S. Army in 1979, to replace the Bell UH-1 Iroquois as the Army's tactical transport helicopter. It has been used by over 30 countries. The UH-60 Lima variant is a UH-60A with upgraded engines, improved durability gearbox, and updated flight control system. Over 600 have been produced from 1989 to 2007, and many UH-60A have been converted to 60 Lima configuration. On this mission, we will learn how to do a cold start on the Sikorsky UH-60 Lima helicopter, following the procedure of the real aircraft, adapted for DCS. The cold start procedure includes the following sections. Before starting engines. Cockpit equipment checks. Starting engines. Engine run-up. The approximate mission time is 20 minutes. Press spacebar to begin. If the cockpit interior is too dark, activate the flashlight with left Alt plus L. If the yellow cross cursor is not visible, press left Alt plus left Shift plus C, to show it. You can adjust the sound volume produced by the background air traffic, by moving the in-cockpit sound slider, on the DCS options, audio screen, which you can access by pressing the Escape key. This instructor's volume level can be adjusted with the helmet sound slider. Also, you can press spacebar to skip long voiceovers. Press spacebar to continue. To request fuel or armament prior to having electric power, it's necessary to open the pilot door, or the ground crew won't be able to hear you. The door is not clickable yet. Press left Ctrl plus C to open it. Good, now press the / key, or the control that you have assigned to the press to talk button, to invoke the communications menu. Now press F8. Ground crew. F1. Rearm and refuel. The mission resources window will be displayed, where you can configure the following. Internal fuel. Quantity of countermeasures and chaff, interlinked, as they are loaded on the same dispenser space. Loadout, where you can select amongst predefined loads for the external pylons and internal spaces of the aircraft. Livery, where you can change the outside skin of the aircraft. Board number. It's an identification number that some liveries can display. As an exercise, load 4 external 200-gallon fuel tanks, either with a predefined loadout, or by right-clicking the loadout boxes below the aircraft illustration. Please note that the total weight of the aircraft, displayed at the bottom of the windows, is now orange. This means it has exceeded the maximum weight allowed. Move the fuel slider to the left, to reduce the aircraft weight until it's below the maximum, say at around 60 to 80%. Click on the green OK button once you have configured as needed. The ground crew will take a brief time to do their job. Wait a bit until they finish.
Request refueling. Request rearming. Copy. Refueling complete. Rearming complete.
Operation completed. Press spacebar to continue the mission. 1. Parking brake. Release, then set. The parking brake is enabled by first press and hold the toe brake pedals. If you don't have physical pedals, press and hold the W key. Do not release it yet. Next, pull the parking brake handle to its fully extended position by clicking on it. Finally, release the toe brakes while the handle is still out. If there is electric DC power, an advisory light will go on, indicating parking brake on. Pressing either pilot or co-pilot left brake pedal will release the parking brakes, the handle will return to the off position and the advisory light will go off. Two. Generators 1 and 2, switches. Set to on, with a right click. The primary electrical system consists of two independent systems, each capable of supplying the total helicopter power requirements. The prime source of each system is a 115, 200 volts AC generator, which generate electric power once the main engines are operating. Three. Air source heat start switch. Set to APU, with a right click. The pneumatic start system uses an air turbine engine start motor for engine starting. 3 pneumatic sources may provide air for engine starts. The helicopter's APU. Engine cross bleed, when one of the engines is already started. A ground power unit. 4. Battery switch. On, with a right click. A 24-volt DC battery provides secondary or emergency DC power, supplied to the battery and battery utility buses for operating DC essential equipment during cold start or primary DC malfunction. The battery switch should be on when either external power, APU generator or main generator power is applied to the helicopter. This will recharge the battery. 5. Caution and advisory panel test switch. Press to test, with a left click and hold. Caution, advisory and warning lights should illuminate steady. Fuel low 1 and 2, caution lights should be flashing. Release the test switch. 6. APU fuel pump. Set to APU boost, with a left click. Fuel is supplied to the APU from the left main fuel tank. The fuel pump switch must be at APU boost for all APU operations, except engine priming. 7. APU control switch. On. The APU system provides pneumatic power for main engine starting and cabin heating, and electrical power for ground and emergency in-flight electrical operations. Placing the APU control switch to on, starts the APU and allows it to operate. Do it now. The APU on, green advisory, has illuminated, indicating that the APU is now running and ready to be used. 8. APU generator switch. On, with a right click. Emergency power is provided by a generator driven by the auxiliary power unit. The APU generator is capable of supplying all flight essential AC and DC bus loads. The green advisory APU gen on will illuminate once the generator is online. 9. The attitude and heading reference system begins its inertial alignment as soon as AC power is being generated. While aligning, it will display both the ALN and the slave flags. Once the alignment is complete, only the slave flag will remain lit. Lighting of the lower console is needed to be able to see the AHRS alignment lamps. 10. Interior and exterior lighting. 10.1. Console lighting. NVG lights are provided for both the upper and lower consoles. Upper console knob. Lower console knob. Adjust as desired. (10.2) Cockpit dome lighting switch. 2 blue, green and 2 white cockpit floodlights are on the overhead cockpit floodlight panel, marked blue, off and white. Set to blue or white, as desired. 10.3 Glare shield lights knob. Adjust 6 lights installed in the instrument panel glare shield, providing secondary lighting for the instrument panel. Adjust as desired. 10.4 Instrument lights. They are grouped into flight instrument and non-flight instruments. The flight instrument lights are divided into pilots and co-pilots. Lights are controlled by individual rotary intensity controls. Co-pilot flight instruments knob. Pilot flight instruments knob. Non-flight instruments knob. Adjust as desired. 10.5. Lighted switches knob. It's a dimmer control to reduce illumination level of lighted button switches, on the command instrument system panels, the miscellaneous panel, and the Stabilizer control panel. Please note that the bright dim test switch, at the caution and advisories panel, works as a toggle for this knob, switching between maximum brightness or rotary dimmer. Adjust as desired and press spacebar to continue. Position lights. As desired. The position lights are outboard at the left and right landing gear support and top tail pylon. The lights are red on the left, green on the right, and white on the tail. You can set them to dim or bright, and steady or flash. Infrared position lights are installed within close proximity of the standard position lights. NVG operation is selected through the nav lights toggle switch, with positions norm and IR. You can use the F2 external view key to check how they look. Select F1 to return to cockpit view. Anti-collision lights. As desired. This light system contains 4 strobes in 2 separate units, one beneath the aft fuselage and one on top of the aft pylon section. Each anti-collision light assembly contains 2 lamps, the upper lamp within a red lens for night operation and the lower within a clear lens for day operation. 10.8. Formation lights. As needed. These lights are on top of the main pylon cowling, tail drive shaft cover, and horizontal stabilizer. The system consists of 4 green electroluminescent lights, controlled by a single rotary switch, with marked positions often 1 through 5. Position 5 being the brightest. 11. We will now radio contact our airbase air traffic controller, to ask clearance for starting engines. The UH-60L is equipped with 5 communications radios. 1. ARC-201, FM. 2. ARC-164, UHF. 3. ARC-186, VHF. 4. ARC-201, FM. 5. ARC-220, HF. The intercom panels, on both pilot and co-pilot side, govern receiving and transmitting on all radios, as well as provide a master volume tool. Currently only the pilot intercom is functional. In order to communicate, you must first select the correct radio on the intercommunications panel for transmitting. For this mission, turn the transmitter selector knob to the number 2 position, the UHF radio. Good. Now when you press the PTT button on the hoods, you will be transmitting using the UHF radio. By default, the receiving switches on the intercom panel are all set to their on position, so that you will be able to hear incoming transmissions on any of them. Just to make sure that we are in fact communicating through the number 2 radio, UHF, please turn all other reception switches, 1 and 3 TROT 5, to the off position. Good. Now we will configure the UHF radio, in order to contact ADC. 11.1. Set the UHF function knob to main or both, to activate the UHF radio. Main enables just the main receiver and transmitter. Both enables in addition a guard receiver, to monitor the emergency guard frequency of 243 MHz. The UHF radio has 2 modes of operation. Manual, for manually tuning the desired communication frequency using the 5 tuning knobs. Preset, for tuning one of the 20 predefined channels programmed on the radio. Press spacebar to input the ADC frequency manually, or press backspace to use a preset channel with the same frequency. 11.2. The mode knob is already set to its manual position. Anderson ATC uses the 250.1 MHz frequency. Enter the frequency manually, using the 5 tuning knobs. 11.3. Good, the radio is now correctly set for calling Anderson Air Traffic Control. 12. Request startup clearance. Click the Press to Talk button that you have bound on your HOTAS to get the radio communications menu. Press F5 for ATC, select the Anderson Airbase, and then request clearance for startup. Press spacebar once ATC has granted the clearance.
Enfield 1-1. Cleared for startup.
13. Automatic Flight Control System. Configure. The AFCS enhances the stability and handling qualities of the helicopter. It is comprised of 4 basic subsystems: Stability Augmentation System, Trim System, Flight Path Stabilization, Stabilator System. 13.1. SAS. The Stability Augmentation System provides short-term rate damping in the pitch, roll, and yaw axes. In addition, both SAS-1 and SAS-2 enhance turn coordination at airspeeds greater than 60 knots. SAS-1. Leave off for now, because lack of AC power causes erratic operation. When this condition is encountered in flight, the pilot must manually disengage SAS-1. SAS-2. Set to on. 13.2. Trim System. When the trim is engaged on the auto flight control panel, the pitch, roll and yaw trim systems are activated to maintain position of the cyclic and tail rotor controls. Proper operation of the yaw trim requires that the boost on the auto flight control panel be on. Trim. Set to on. Boost. Push on. 13.3. Flight Path Stabilization. Proper FPS operation requires that the boost, trim and SAS-1 and or SAS-2 functions have been set to on. FPS, push to on. 13.4. Stabilator System. The helicopter has a variable angle of incidence stabilator to enhance handling qualities. The automatic mode of operation positions the stabilator to the best angle of attack for the existing flight conditions. Check that auto control is on. When the automatic mode is engaged, no further pilot action is required for stabilator operation. 14. Stabilator. Check. The stabilator position indicator should be between 34 and 42 degrees down. 18. Avionics Systems. Set to on. 18.1. Doppler GPS Navigation System. Set to on. The DGNS provides accurate aircraft velocity, position and steering information from ground level to 10,000 feet. The system provides worldwide navigation, with position readout available in both military grid reference system and latitude-longitude coordinates. Up to 100 waypoints may be entered in either format. Set to on by turning its mode knob to either MGRS or LOT long. Press the ENT page button to accept its startup data. Press ENT a second time to accept the DA-FIF status. You should now be on the Wind UTC data page. The DGNS is now ready for flight. On a future training mission we will learn how to navigate through waypoints with it. 18.2. Adf Navigation Radio. Set to on. The ARN-149 is a low-frequency automatic direction finder radio, providing compass-bearing capability within the frequency range of 100 to 2199.5 kHz. You may wish to use the number 2 key to change to the co-pilot seat, to have a better grasp of the ADF controls. The number 1 key would return you to the main pilot seat. The ADF has 2 functional modes of operation, ANT or ADF. The antenna mode functions as an aural receiver, providing only an aural output of the received signal. The ADF mode functions as an automatic direction finder, providing a relative bearing to station signal to the HS sign number 2 bearing pointer, plus the aural output to identify the station. For this mission, set it to ADF. Next, use the knobs to input 03850 to practice tuning to the frequency of AJS station at 385.0 kHz. Good, the ADF is now operating and tuned to the AJS station. After a few seconds you should be able to hear its identification Morse code. Unfortunately, you can't silence the beep, as the ADF unit's volume noise reception switch on the COM panel, are implemented yet. 18.3. VOR, ILS control. Set to on. This radio set can be used as a VOR or ILS receiver. The desired type of operation is selected automatically, by the frequency of the tune station. Course information is presented by the vertical situation indicator deviation pointer and the bearing pointer number 2 on the HSI. The combination of the glide slope and localizer capabilities makes up the instrument landing system. The marker beacon portion of the receiver is not yet simulated. Turn on the VOR, ILS receiver, flicking its power test switch to on. For this mission, tune Anderson ILS at 110.1 MHz. Good, the VOR, ILS is now operating and tuned to one of Anderson ILS stations. After a few seconds you should be able to hear its identification Morse code. As with the ADF, its volume control nor reception switch on the COM panel, are implemented yet, so we can't silence the beep. (18.4) Check Ahrs. The slave indicator must be lit and the alignment should be complete. ILN indicator is off. Check that HSI heading matches the one on the magnetic compass. You may illuminate the compass with the highlighted switch. (18.5) Radios. As needed. We already have the UHF radio tuned to Anderson ADC. Let's tune the other radios, for practice. 18.5.1. Vhf Fm radio. This set provides communications of voice and data, secure or plain text, and homing, over the frequency range of 30 to 87.975 MHz. The UH-60L equips two of these radios, one for the pilot and another for the co-pilot. We will use the pilot's one. To turn the radio on, switch its function selector to squelch on. We will now tune the radio to 38.6 MHz, which is a frequency for Anderson ATC. You can obtain that kind of data using the F10 key, to call up the map view, and then click on the blue icon on the middle of Anderson runway. Begin by pressing the frequency button. Next, use the radio keypad to input 38600, and then press its enter button. Good, now select this radio as the transmitting one. By turning the communications panel selector knob to 1, as this is radio number 1. To make sure that you only hear audio from radio 1, switch all other radios, 2 through 5, to off. Good, now press the PTT button on your HOTAS and on the communications menu select F2. Request hover check. If the radio is tuned correctly, you should hear a response from ATC.
Infield 1-1. Infield 1-1. Cleared for hover check.
18.6. RWR. As needed. The APR-39 radar warning receiver detects and highlights radar threats. Alongside the visual display, it also has an audio warning output, which can be controlled using the volume dial on the co-pilot side panel. The display brightness can be controlled using the dial on the screen. The current implementation of the RWR is simplified and only detects the threats shown on the figure. To activate the RWR, set its power switch to on. 18.7. Helmet mounted sight. As needed. The AVS-7 heads-up display serves as an aid to pilots during night flight operations, by providing operational symbology information about the aircraft. To enable, switch the highlighted switch to on, or use the left Ctrl plus H keys. To adjust the HUD brightness, you need to bind the following controls on your DCS. AN, AVS 7, brighten. AN, AVS 7, dim. Barometric altimeters. Set. 2 barometric altimeters are installed on the instrument panel. The altimeter's operating range is from -1,000 feet to 50,000 feet. The face of the instrument has a marked scale from 0 to 9 in 50-foot units. A window on the lower right section of the instrument face indicates the barometric pressure setting. Use its left knob to adjust it to the airfield pressure. 21. Radar altimeter. Set low and high alarms by turning its knobs. The radar altimeter provides instantaneous indication of actual terrain clearance height. Altitude, in feet, is displayed on 2 radar altimeter indicators on the instrument panel in front of the pilot and co-pilot. The indicators each contain a pointer that shows altitude on a linear scale from 0 to 200 feet, and a second linear scale from 200 to 1500 feet. An on, off, low altitude bug set knob, on the lower left corner of each indicator, serves as a low-level warning bug set control, and an on-off power switch. Turn it clockwise to set the radar altimeter to on. Good, now set the low bug to 80 feet. Then, turn the right knob clockwise to set the high altitude bug to 800 feet. .23. Starting engines. To start a jet engine we need 3 things. Fuel, air and electric power to ignite the mix. The APU that we have already started, provides the air and the electric power, now we need to provide the fuel. 1. Engine fuel system selector. As required. A separate suction fuel system is provided for each engine, with fuel being stored in 2 internal tanks. Each fuel system has a selector valve which is manually operated through the engine fuel system selector lever, on the overhead engine control quadrant. With the fuel levers at off, the control valves are closed, allowing no fuel flow to the engines. Use the mouse to advance both fuel levers to the deer position. You may find it easier to move the left lever from the co-pilot's seat. When the levers are moved forward to the deer position, the selector valves are open, providing fuel flow for each engine from its individual fuel tank. If a tank is empty, or you need to equalize fuel in the tanks, the lever of the low-level tank is moved to the XFD position. This connects that engine to the other tank through the crossfeed system. 7. Start first engine. Either engine can be started first, but for this training mission, we will start the right engine first, engine number 2. 7B. Starter button. Press and hold until NG speed 2 increases, then release. When the start button is pressed, air from the selected source, on this case, from the APU, is directed through the start control valve to the engine start motor. The number 2 engine starter caution light will go on at this time, and remain on until the starter drops out. NG speed is the engine compressor speed in % of RPM. 7C. Turbine gas temperature. Check it's below 150 degrees Celsius, before advancing the engine power control lever to idle. 7D. Engine power control lever. Advance the right lever to its idle detent, for light off and initial acceleration, by clicking on its base. 7E. System indications. Check. Monitor the increase of engine number 2's TGD, and NG speed. 7F. Engine starter caution light. Note it will turn off between 52 to 65% NG speed, meaning that the engine starter has disconnected. The engine should attain an idle speed between 63 to 66%. Press spacebar once the engine 2 attains this RPM. 8. Start second engine. For this training mission, we will now start the left engine, engine number 1. Following the same procedure we just did with the right engine. 8B. Starter button. Press and hold until NG speed 1 increases, then release. The number 1 engine starter caution light will go on at this time, and remain on until the starter drops out. 8C. Turbine gas temperature. Check it's below 150 degrees Celsius, before advancing the engine power control lever 1 to idle. 8D. Engine power control lever 1. Advance the left lever to its idle detent, for light off and initial acceleration, by clicking on its base. 8E. System indications. Check. Monitor the increase in temperature and NG speed for engine number 1. 8F. Engine starter caution light. Note it will turn off between 52 to 65% NG speed, meaning that the engine starter has disconnected. The engine should attain an idle speed between 63 to 66%. Press spacebar once the engine 1 attains this RPM. 9. Systems. Check. Once both engines attain a stable idle RPM, check the following items. 9A. NG speeds should be 63% or greater, and within 3% of each other. 9C. Transmission pressure. Check. Transmission oil pressure should be between 30 to 65 psi, and not surpass a maximum of 130 psi. 9D. Engine's oil pressures. Check. Engine's oil pressure should be between 26 to 100 psi, and not surpass a maximum of 120 psi. 9E. Hydraulic pumps 1 and 2 caution lights. Check they are off. 14. Engine warm-up. If ambient temperature is below -17 degrees Celsius, warm engines at idle for 3 minutes. Not applicable for this mission. 8.24. Engines run up. 2. Engine power control levers. Advance into fly position, moving them with the mouse. Gen caution lights 1 and 2. Check they are off. Once the aircraft engines attain sufficient RPM, the generator of each engine will start functioning and be brought online, producing AC electric power. 7. Torque percentage 1 and 2. Check they are matched within 5%. The torque percentage shows the amount of power each engine is delivering to the main transmission. 9. APU fuel pump switch. Off. As the engines are now self-sustained, we will turn off the APU. This begin by turning off its fuel supply. 9B. APU general off. Turn off the APU generator, as the main engine's generators are now providing full electric power to the aircraft. 10. APU control switch. Off. This turns off the APU. 11. Air source heat start switch. Set to ENG, so that the main engines are now providing bleed air. 12. Engine fuel system selectors. Leave them at dear, unless there is an imbalance on the fuel amounts of the internal fuel tanks. 13. SAS number 1. Set to on. Now that we have the main AC generators online, we can enable the SAS1 channel of the stability augmentation system. Doppler GPS mode select switch. On the instruments panel, set Doppler GPS and nav mode buttons to on, to have them ready for navigation. Congratulations, this completes the cold start procedure. It seems kind of long because of all the explanations, but we promise you'll be able to perform it in just a few minutes. Press spacebar to exit from the mission.